You guys to the best math channel in the world, say on Bizzy Made It Easy channel. We are here once again to have fun when it comes to mathematics. This is the only channel we make mathematics fun for everybody. And if today is your first time seeing us, don't forget to hit the subscribe button, like the video, then share to everyone. Say you're on Bizzy on all social media platforms, on TikTok, on Facebook, then on Thread and Instagram as well. Now, the coordinate geometry lesson has come to an end. We started and we have treated everything under coordinate geometry. Today, we are going to talk about another interesting lesson, another examinable area in mathematics when it comes to WASI, BC as well, which is binary operations. We are going to talk about binary operations. Now, we know we've heard the word binary. Yes, binary. So the word binary means only two. Yes, so when you hear the word binary means only two. Yes, and operations. In math, we use certain operation signs or symbols in our calculation. So we have the addition sign, the subtraction, the multiplication, the division, the less than, greater than, less than or equal to, greater than or equal to, not equal. These are operation signs. Yeah, these are operation signs. But today, our lesson on the binary operations, we are going to combine these two. Yes, but we are not going to use these operation signs. We are going to use different operation signs as it will be given. And we have so many binary operation signs. Yes, when it comes to binary, there are some symbols and signs that we use. Now, binary operation simply means that combining two values to obtain a new one, or is a rule for combining two values to obtain a new one. Combining only two values to obtain a new one. So when you see an operation defined as, so let me even give some examples of the operation or the operators you are going to use. So you can see something like the star, a triangle like this, then another one like this. See something like a square with a dot inside. You can see something like a circle. Then you can have so many. You can see some like the cone. Yes, some like the cone and so many operations. So in binary operation, this is what we are going to use. We are going to use this one to combine figures or elements. Then the rule will be given. So when you say a binary operation, AB is defined as maybe 2A minus B. We have used the operation to combine this using the new rule. So we have combined these two variables. Yes, using the new rule. So when you are going to solve, although they have combined these two values or these variables, you are going to work with a given what rule. So when you solve, you see that you obtain an answer by following this rule. And this is just the introductory lesson on the binary operation. And don't forget to subscribe. Keep watching as we try to take our first question on this to see how questions on binary operations are solved. On the screen says that the operation, which is looking like the star, is defined as m operation n is equal to m plus n plus mn. We have to evaluate I, 3 operation 4, then I 4 operation 3. So the operation was defined as m operation n, which is equal to m plus n plus mn. As the question gave, we have to evaluate I, 3 operation 4, then I 4 operation 3. We have used this operation to combine the 3 and the 4, for which we are to apply this rule in solving this. So what you need to understand is that, let me repeat the rule, is m plus n plus mn. What you have to understand is that first thing first. First thing first means, to me, means that the first letter for the first number, then the second letter for the second number. So here we have m and n, and we have 3 and 4. So it means that the m will take the 3, then the n will take the 4 with this rule. So we are going to have 3 plus 4 plus 3. This will multiply, they are together. So this will give us 3 plus 4 plus 12. 3 plus 4 plus 12. So for which this one will give us 3 plus 4 is 7, then plus 12, which is going to give us 19. So with the new rule, 3 operation 4 according to the new rule will give us 19. Simply solve. So this is how we solve questions like this. So the I is 3 operation 4. So here we have to solve 4 operation 3. So I'll quote the operation again. We have m plus n plus mn. So here it's going to change. You see, here was mn, which is 3, 4. So here now, the m is going to be the 4 and the n is going to be the 3. So I have 4 operation 3, which is equal to, so we have 4 plus 3 plus 4 times 3. So you follow the letter as they appears against the what? The numbers. So this will give me 4 plus 3 plus 4 times 3, which will also give me 12. So this will give me 4 plus 3, 7 plus 12 again, which will give me what? 19. Since I'm using all addition, now there's a property or properties of numbers that says addition and multiplication are commutative. And I'm going to explain it on this channel. I'm going to explain the properties of numbers, the associative, the distributive, the commutative property relating to binary operation. That's why here I obtained the 1919. 2 plus 4 is 6. And 4 plus 2 is 6 because they are addition. So here, this is just the introductory lesson or question we have solved. So it's very simple and easy. Simplify this, or we simplify math lesson on this channel. Continue watching as we take the next question. So the next question says that binary operation is defined over the set of real number R as A operation B is equal to A minus 3B. So find I, 5 operation 2, then II 2 operation 5. Similar to the first one with a different rule. So the operation was given as A, like O, then B, which is equal to A minus 3B. So the I was given as 5 with the operation 2. Then the II was given as 2 with the operation 5. So we are going to solve. So this one, it means the A is 5 and the B is 2. Following the operation, A minus 3B, which means 5 with the operation 2 will be A. A is 5 minus 3 times the 2. The 3 is multiplying. So I'll have 5 minus 3, 2 is 6, which will give me negative 1. So this is how we simplify this one. 5, 2, AB. 5 is A, then the B is 2. We follow the rule. So we have combined it with a new rule and we have obtained a new set of answers. So we are moving on to the II, which is 2 operation 5. And the operation was given as A, operation B is A minus what? 3B. So here our A is 2, then our B is 5. So following 2 operation 5 will give us A, which is 2, minus 5 times the B. Oh, sorry, 3 rather. 3 times the 5 was 3B, 3 times the 5, which will give us 2 minus 3, 5 is 15. So 2 minus 15 will give us negative 13. So this, the first one gave us negative 1, the second one gave us negative 3. Why didn't you get the same answers as we did in the first time? Only addition and multiplication are commutative. And I've told you I'm going to have a lesson, a video on that. So subtraction is not commutative. This is what I mean. If you have 2 times 5, it's 10. If I have 5 times 2, it's 10. 2 plus 5 is 7. 5 plus 2 is also 7. So addition and multiplication, we say they are commutative. Anyhow you interchange them, you obtain the same answer. That's why in the beginning, the operations were all addition, we obtain the same answer. So in case you need explanation, there's a reason why. Let's take more interesting questions on this. Keep watching. Question on the screen. A binary operation is defined on the set Q of rational numbers by x operation y is called x plus y plus 2y. We have to evaluate I, the 3 on 4 operation 1 on 2, then I negative 8 operation 6. So the operation was x operation y is equal to x plus y plus 2xy. So the I says we should solve 3 on 4. Then with the operation 1 on 2. This involves fraction. So pay more attention here. So with this, we need to understand that the x is 3 on 4, then the y is 1 on 2. Yes, so 3 on 4 operation 1 on 2 will be equal to now the x here, 3 on 4 plus 1 on 2 plus now 2 times the 3 on 4 times y, which is 1 on 2. These are multiplying. Yes, these are multiplying. So follow closely. So this one will give me 3 on 4 plus 1 on 2 plus, now these are multiplication of fraction. We can cross divide if possible. So this is also over 1. So we can cross divide. The denominator here can cross out any of the numerators. Then if possible, you do that. So the 2 here can divide itself 1, divide here 1. If you don't understand board mass, there's a video on that on my channel. You can go and check it out. So multiplication and division of fractions, we don't find the LCM. We find the LCM for only subtraction and addition. So 1 on 1 is the same as 1. So 1 times 3 is 3, times 1 is 3 again. 1 times 4 times 1 is also 4. Now you have gotten addition throughout. What do we do here? We find the LCM. What's the LCM for 4? 2 and 4 is going to be 4. So that's the least and common multiple for these denominators. 4 divide itself 1. 1 times 3 is 3. 2 divided 2, 2, 1, 2. Then 4 divide itself again. 1. 1 times 3 is 3. So this will be 3 plus 2 is 5. Plus 3 is 8. So 8 on 4, for which when you divide, you are going to get 2. So 4 will divide itself 1. Then you divide 8, 2. So 2 on 1 is the same as 2. So easily solved on this channel. So you follow closely. You can pause the video or you go back. Then you solve and see if you get the same answer. So let's solve the II. The II. The II is negative 6 operation 6. So with the same preamble here, our x is negative 8. Then our y is 6. So negative 8 operation 6 will give us negative 8 plus 6 plus 2 times negative 8 times 6. So I put them in bracket. Replacing the bracket, you can use the multiplication sign. It's the same thing. So let's solve it step by step. So negative 8 plus 6 here. Now we have to be careful here. Positive 2 times negative 8 will give you what? Positive times negative. Positive 2 times negative 8 will give you negative 16. Yes, negative 16. Here has given negative 16. Then negative 16 times negative 96. Yes, negative 96. Positive number times negative now will give negative answer. Times another positive, you get a negative answer. So negative 8 plus 6. So addition and subtraction. Board mass, addition comes before subtraction. So negative 8 plus 6 will give you negative 2. Then minus 96. Yes, I don't want to jump steps. I want to move step by step. So that you get it. It's not every level that we use calculators. So you need to understand. So you are owing 8 and you paid 6. So you are going to go to, so negative 2 minus 96 will give you negative 98 because you're owing 2 and you want to borrow 96. So you are going to owe 98. So the operation with the new rule has given us negative 98 and the first one to give us 2. That's easily solved on this channel. If you follow the lesson, I've taken my time for everyone to understand. Continue watching, subscribe, like, and share to all students. Let's solve another question on this. Another operation is defined by the operation B is equal to a squared minus 2ab, where a and b belongs to, that symbol there, it belongs to r. R in numbers, real number. Find bracket open 3 operation 5 bracket close, operation 5 bracket open 5 operation 3 bracket close. So this looks complex. So we have A operation B, which is equal to a squared minus 2ab. Yes, and we have to find bracket open 3 operation 5, then another operation 5 operation 3 brackets close. Now don't be confused here. These are two different operations they have combined. Yes, they have combined. And what you need to understand is that you solve the first bracket first, you obtain an answer. You solve the second bracket first, you obtain an answer. Then you use the same rule to solve both answers separately. So watch out. This is what I mean. So I'm going to solve the one in the first bracket. The first bracket is 3 operation 5 with the rule a squared minus 2ab. So with this, our a is 3 and our b is 5. So follow closely. So a squared, which is 3 squared minus 2 times a is 3. Then b, which is 5. Now 3 squared, 3 times 3, which will give you 9, minus 2, 3, 6. Then 2, 3, 6, 6, 5, 30. Yes. 2, 3, 6, 6, 5, 30. They are multiplying. The answer you obtain here, you need to multiply the next one. 9 minus 30 will give you negative 21. This for the first bracket. Yes. Now let's solve for the second bracket. Second bracket is 5 operation 3. With the same rule, a squared minus 2ab. So follow closely here. So here our a is 5 now. Then the b is 3. So I'm going to use the same rule. So this one will be 5 squared minus 2 times a, 5 times 3. 5 squared is 25 minus 2, 5, 10. 10 times 3 is what? 30. So 25 minus 30 will give me negative 5. Yes. Now with the first bracket, I got negative 21. Second bracket, I got negative 5. So I've obtained answers for this. So I'm going to apply the same rule. The same rule which is saying a operation b is equal to a squared minus 2b. Now I'm going to combine these two. The answer here. So here negative 21 operation negative 5. So in this case, my a is now negative 21 and my b is now negative 5. Yes. So this is what it means. The answers you get, combine it, then apply the same rule to solve it. Yes, this is what this expression means. So now I've gotten here a bracket negative 21 squared. So negative 21 squared will give us negative 21 squared will give us 441. Then negative 2 times negative 21, positive 42. Then positive 42 times 5. 210. 210. Be careful. This negative multiplying negative, positive. Positive multiplying negative is negative. 210. So 441 minus 210. 441 minus 210 will give us 231. So this is how we solve this question. Yes, this is how we solve this question. When you see any operation like this, solve this separately using the operation, the rule. The answer you obtain with this operation, you solve the second. Then when you finish, you combine them. Binary operation, we deal with two elements. So you get one here, combine using the operation. You apply the rule, then you solve it easily. So I have taken my time to solve the first bracket, second bracket, then I'll obtain my final answer. So keep watching. Let's take the next question. Next question on the screen says the operation is defined on the set of real numbers, m operation n, then with the numerator m minus n over denominator n, for which n is not equal to 0. So A say we have to evaluate three operation bracket open 5, operation 2 bracket close. Then the B says find the true set of I. 8 operation K is equal to 12 operation 3. Then A operation 8 is equal to 12 operation 3. These are different set of questions. So first of all, I'm going to write the operation, which is m operation, which is m minus n all over n. So the A says 3 operation bracket open 5 operation 2. Now, as I explained in the previous video, you solve the one in the bracket first. Yes, the one in the bracket first. So I'm going to use the first one, 5 operation 2. And the answer you get here, you combine this and the answer you get here as two elements. That's binary operations. So with operation, so here, now m is 5 and n is 2. So follow closely. So we have now m 5 minus 2 all over n, which is 2. So 5 minus 2 will give us 3 all on 2. So we have solved this one. It has given us 2. So now we have to combine the 3 as our left side element. Then this one will become our right side element. So now I'm going to have 3 operation 3 on 2 with the rule m minus n all over n. So here my m is 3. Then my n is 3 on 2. Follow closely as I continue here. So m minus n. So m is 3 minus n. N is 3 on 2. So let me solve this first. Okay, let me write even all on, then n, 3 on 2. So these are subtracting. So I'll solve it, then I'll divide by this answer. So 3, the same as 3 on 1, then 3 on 2. I have to find the LCM will be 2. 1 will divide here 2 times 2, 3, 6, minus 2 divided 1. 1 times 3 is 3, which will give me 3 on 2. So the numerator is giving me 3 on 2. So now I have 3 on 2 divided by 3 on 2 again. Yes, this is dividing. This means they are dividing. So 3 on 2 as the answer on top, divided by 3 on 2 again. So division of fraction, you know, so 3 on 2, it will change to multiplication. You turn the fraction upside down. So this one, instead of 3 on 2, I'm going to get 2 on 3. It has become multiplication. I can cross divide. 3 divide here 1, 3 divide here 1, 2 divide here 1, divide here 1 times 1 is 1, all on 1, for which I'm going to get 1. Yes, for which I'm going to get 1. So the operation 3 bracket 2 5 2 will give me 1 as the answer. Yes, so this is one, which is the A. It's very simple. Anytime you see element in bracket, you solve the one in the bracket first. If you see two brackets, solve them separately. Then when you finish, you combine them. You always need two operations. Yes, or two elements. Then we use the rule to solve. So this is very simple. You follow step by step. And sometimes when I write a question, you pause the video and solve to see if you get the same answer. Now let's look at the B. Operation. That's the B. The same operation. So we are going to use to solve the BI. The BI says we have, and this one we are finding the true set. 8 operation K is equal to 12 operation 3. These are two different operations separated by the equal sign. We are going to solve them together. Because of the equal sign, we are going to solve them together. So when you take the first one, 8 operation K, the M is 8. Then the N is equal to K. And when you take the second operation, 12 operation 3, the M is 12 and the N is 3. Now I'm going to substitute this back into each of the operations. So the operation is there. So the first one is M, which is 8, minus the N, which is the K, all over N, which is the what? The K, which will equal to the second element here. The M is 12. Then the N is 3. All on 3. So when you see any operation involving the equal sign like this is how we solve them together. This one, there's not the symbol of the operation. This is an operation which is the equal sign. So you solve them together. So we are going to solve the true set and have N minus K all on K will be equal to, now I can simplify this. 12 minus 3 will give me what? 9. 9 on 3. I can simplify to get a single answer. But here I'm going to cross multiply. So cross multiply, 9 will multiply K, which will give me 9K. Then times 3, let me even write it step by step. 9 times K, then I'll have 3 times 8 minus K. So this will give me 9K is equal to 3, 24, then minus 3K. Follow closely this simple equation. So I have 9K is equal to this 3 will cross the equal sign, positive 3K, which will give me 24. So 9K plus 3K will give me 12K, which will give me 24. How do we get our K? We divide both sides by 12 to get our K. Here we divide the 1, so our K is equal to 2. As simple as that. So here the truth set. The truth set is K is such that K is equal to 2. So this is how we solve this question. When you see an operation sign or when you see a question like this, you just substitute it back into the operation, then you solve them as such. Assuming this was another operation sign, or assuming this was an operation sign, like we solve this separately, then we solve this separately to get two answers, then we use the operation to solve as we did. So by this one, because of the equal sign, this is how we solve it. We get a simple term. So let's look at the BII, the BII. So with the same operation sign, we have to solve K operation 8 is equal to 12 operation 3. So the first one, K operation 3, sorry, K operation 8. Our M is K and our N is 8. With the 12 operation 3, M is 12 and N is 3. So we substitute it back into the operation and solve them at the same time. So with the top one, using the operation, I have K minus 8. Since it's M minus N, then all over N, which is 8. is equal to this one, n minus, so 12 minus 3 all on 3 once again. Yes, all on 3 once again. Yes. So I'll solve here 8 minus a minus 8. Then I'll solve this to it on 3. I'm going to cross multiply again. I'm going to cross multiply. Now looking here, here is 8. So when I cross multiply, I get 3 bracket open 8 minus a minus 8 is equal to 9 times 8. So opening the bracket, 3k minus 24 is equal to 9 times 7 will give me 72. Yes, 9 times 7 will give me 72. So I have 3k, I have to group like 10, 72 plus 24. So I have my 3k. So I have to divide both sides by 3. Both sides by 3. You will divide here 1. You will divide here 32. So this has given me 32. So the truth set is k is such that k is 32 as the answer. So this still on binary operation. So when you encounter a question like this, don't fumble. Just follow the principle and solve them as I'm explaining on this channel. Keep watching as we take more challenging questions and simplify them here. The operation is defined over the set of real numbers by A operation B is equal to A plus B as numerator, then over the denominator A minus B. We have to find I. 2 operation bracket open 3 plus 1, the II. 2 operation 3 plus bracket open 2 operation 1 bracket close. So 2 different questions with the same operation. And the operation was defined as A operation B is equal to A plus B all on A minus B. So we have to solve 2 operation 3 plus 1. Yes, normally we see the 3 or we see a number plus the operation, not the operation sign here, like the addition and subtraction. So here, the addition is just to confuse you. So here will be 2 operation 4. Just add them to obtain your 2 elements and apply it and solve. Yes, unless it's an operation, the same operation. That's when you solve the brackets separately. Then you come and combine the 2 and the answer you obtain here, as we have solved previously. So with this one, with the same operation, so here, now the A is 2, and the B is 4. So we can put it back into the equation. So 2 plus 4 all over, then B, 2 minus 4. So 2 plus 4 is 6. Then 2 minus 4 is negative 2, for which when we divide, yes, for which when 2 can divide the 1, negative 3. So the answer will be negative. Anytime negative divide a positive answer, the answer will be negative. So simply this is how we solve the I. Yes, the I that was given. So let's use the same operation to solve the II. Plus 2 operation 1. Yes, 2 operation 1. Now this one, because of the addition sign here, we are also going to solve them the same time. We are going to solve them at the same time. So with the first one, with this one, with the 2 operation 3, the A is 2 and the B is 3. And with the 2 operation 1, A is 2 and B is 1. So we are going to solve them the same time using the operation. So the first one, A plus B, which will be 2 plus 3, all over the A minus B, 2 minus 3. As we did the equal sign, then plus 2 operation 1, which is 2 plus 1, all over then 2 minus 1. So follow closely So the top one will give us 5 over the next one, -1, plus the top one will give us 3, then minus 1. So 1 divided by -5 will give us -5, plus 1 divided by 3 also give us 3. So -5 plus 3 will give us -2. You owing 5 and you paid 3. So you are going to owe -2. That's why when the point is, you get -2 on the calculator. So don't be scared. This is how this is solved. Now keep watching as we take more challenging questions and solve them here. Our last question. So say that the operation is defined on the set of real numbers R by x operation y is equal to x plus y on 2, where x and y belongs to real number. Or yes, they belong to R, which is a real number. So the first one says we have to evaluate 3 operation 2 on 5. Then the II says if 8 operation y is equal to 8 1/4 or 8 1 number 1/4, find the value of y. So the operation was x. Operation y is equal to x plus y all on 2. So let's solve the first one, which is 3 operation 2 on 5. So with this, we can see that our x here is 3 and our y here is 2 on 5. 2 on 5. So following the operation, we have 3 plus 2 on 5 all divided by 2. So I will solve the top one first. So 3 on 1, then 2 on 5. Every whole number is over 1. So when I come to R, I normally write over 1. Yes, to make it a fraction form so I can solve. The LCM is 5. 1 divided here 5. 5 3 is 15. Let me even bring it out small. 5. 1 divided here 5. 5 3 15. Plus 5 divided here 1. 1 times 2 is 2. Which will give me 17 on 5. So the top one is giving me 17 on 5. So follow closely as I continue. So I have 17 on 5 divided by what? 2 is division. So I can write it like this. I write this one over 1. Division of fraction will change to multiplication with the second one. The second fraction, you turn it upside down. So I have 17 on 5 times 1 on 2. For which one I solve? This one will give me 17 on 10. For which you can change it into mixed fraction or decimal. So 10 will go into 17 one time. Remember 7 all on 10, or in decimal form, which will give me 1.7. So this is how we solve this. The top one is a fraction. Yes, you solve it. You don't understand how to solve board mass or fractions, they are on my channel. You can go and watch the video I've done on board mass and you understand how to add and subtract fraction to your best knowledge and best understanding. So you solve it, then divided by the down one, any operation like this. So when you see 5 on 2 like this, can be written as 5 divided by 2. Yes, and when you watch the video on board mass, you understand it better. So this is how this is. So we are going to take the II and see how we are going to solve the II too. So you find the value of y if, so we have 8 operation y is equal to 8 whole number 1 on 4. Don't be confused. This is like the equal sign question that they gave us. So you can go back and watch and solve and see if you get the same answer as I'm coming to do here. So with this one, the operation, so what you have to understand is that here x is 8. Then the y2 is y. The y here will replace this y. Yes. Then you have to change this one into what? Improper fraction. Yes, improper fraction. So 8 times 4 is 32 plus 1. 33 on 4. So we change it to what? Improper fraction. And that's how we change it. Now let's put it back into our operation. So x on y. So we have 8 plus y all on 2 is equal to now 33 on 4. We have gotten a simple equation that we can find the LCM or cross multiply. Yes, so I'll cross multiply here. A plus y is equal to 2 times 33. Can use the bracket. So 48 is 32 plus 4y is equal to 66. Then I have to group like terms. So I'll leave the 4y here since that's the one I'm looking for. Then I have 66 minus 32. Let me continue here. So I have 66 minus 32, which will give me, okay, here will give me 4y is equal to 66 minus 32, which will give me 34. Yes, that will give me 34. So follow closely. So I'll divide both sides by 4. I'll get y here. So 2 can divide here 17 and divide here 2 times. So here is 17 on 2. Or I can also leave it in mixed fraction form or in decimal form. Whichever way you'll be correct. So 2 can go into 17 how many times? The closest one it can go inside is what? 8. So 2 8 is 16. Remember 1 all on 2. Or you are going to get 8.5 as decimal. Yes, you are going to get 8.5 as decimal. So therefore, the value of y is equal to 8.5. I'll leave it in the decimal form. So these are all past questions I've selected on binary operations. So this is the last question on this introductory lesson, or which is the lesson 1 on binary operation. Watch out for lesson 2, which is relation involving sets. Yes, on binary operation. That's a little tricky. But before that, I will encourage you to watch my lesson on sets, so that when I get to the relation involving sets, you understand it more. If today is your first time, don't forget to subscribe, like and comment, and follow us on all social media platforms. That the best maths channel is here on YouTube. Say you're Bizzy, made it easy channel. Until we meet again, say goodbye and watch out for more.